Okay, so we were saying we're going to turn in our warm-ups today, and we have our warm-up for yesterday was no school, right? Okay, now we just said that we're going to break this down with a factor tree. 2 doesn't work, so we tried 3. 3 times 25, and then we crossed out 75. I don't need it anymore. Now 25, what does that break down to? 2 doesn't work. If you try 3, 3 doesn't work. It's 5 times 5. Cross out 25. Then we circle our pairs. We have a pair of what? Pair of 5s. So circle your 5s, and remember, cross one out. Now, what goes out and what goes in of the radicals? Yeah, the pair goes out. Think about couples are going out, like on a date. Couples go out. Circles go out. So 5 out here, and the loner stays in. Okay, 5 squared to 3. Does everyone remember that from like 2-3 days ago? Okay. Now, 2 days ago, okay, since yesterday was off, we learned how to multiply. Okay, we said outside times outside goes on the outside. Inside times inside goes on the inside, right? So my outside coefficient numbers, 4 and 7, 4 times 7 gives me what? 28, okay? And then square root sign, and then my insides, 5 times 10, 50, okay? Now, if you left it like that, you're on your way, but that's not it. Remember, you want to think, can this break down? I mean, anytime you see a square root, see if you can break it down. Let's try 50. It's even, so 2 times what? 25. And then we did this on the first one. We know 25 is 5 times 5. Do I have a pair there? Yeah, so since I have a pair, I got to break this down. So 50 and 25 broke down. And remember, if there's a number already out here, circle it. It's like a pair outside already. Okay? So the 28 is already outside. The pair of 5 is going outside. So what do I do with 28 and 5? Multiply. 28 times 5 is 140, if you didn't know that. Square root, and what's my loner? 2. Okay? So again, 28 squared to 50 is okay, but 140 squared to 2 is better. You want to break it down if you can. Now, we also learned this 2 days ago. A square root times the same square root takes off the square root. Just that number. So what's this going to be? Just 91. Yeah, that's it. Cool. Okay, that's it for the warm-up. I want you to get out your notes that we've been working on the last 2 classes, and then you can pass up, or I'll come get your warm-up sheets. Now, last time we did this, we did multiplying. Let me remind you real quick. Is everyone looking up here? When we did multiplying, we did outside times the outside. It's going to be written on the outside. Inside times the inside is going to be written on the inside. Okay? So that was multiplying. Reduce it if you can. That's multiplying. We also learned a square root times the same square root is the number that was underneath it. That's it. All right, today, division. When you're dividing, it's just like multiplying. It'll be outside divided by the outside. Oh, and then next to it, inside divided by the inside. No big deal. So let's do that on the left here. So 4 divided by 2 is what? 2. And now inside the square root, 15 divided by 3 is what? 5. 5 is prime, doesn't break down. That's it. 2 squared to 5. Outside divide, inside divide. That's it. Let's do example 6. 6 divided by 2 is what? 3. 10 divided by 5 is what? 2. That's it. You try these 2 down here. The one thing on number 5, this is a 1, by the way. If there's no number, you have an implied 1. So everyone's trying 5 and 6. 8. 4 divided by 2 gives me 2. That's it. 2 is prime. Can't break it down. Now number 6. 2 divided by 2 is not 0. It's 1. Now, before we write that 1, what's square root of 4 over square root of 2? 4 divided by 2 is 2. Now, usually you don't see the 1. It's implied. So you could write 1 square root of 2, or just square root of 2 works out, okay? Now, that's how those work out. Everything's good. Now, this part, rationalizing the denominator. This can be confusing. So everyone's been paying attention, but I want everyone to lock in, okay? This doesn't have to be hard as long as you pay attention. Cool? Now, when we divide numbers, when we're dividing at all, did you know that you're just breaking things into little groups, right? So if I said we're going to break this class and cut it in half, divided by 2, there'd be 2 groups, right? Okay. Now, you cannot break something into decimal groups. Like, I can't break y'all into 1.5 groups. Like, not really, okay? So here's the deal. We don't like to have decimals or square roots on the bottom, okay? So this is one of those no-nos. You can write it, it's something, but you don't want to have a square root on the bottom. That's kind of a no-no. So here's the idea. To rationalize the denominator is to get rid of the square root sign. Now, do y'all know how to get rid of a square root? How? Okay. I think you're kind of on the right track. Now, I already showed you last time how to do this. You didn't even know it. So I'm going to take it from the back of your brain, which you already know, bring it to the front. Scrolling up here. Y'all remember this right here? Check it out. To get rid of a square root sign, I just had to multiply by the same square root, right? So if I have a square root of 2, if I want to get just a regular 2, I have to multiply by the same square root size. You know what I'm saying? So like square root times itself. So here's the dealio. When I see a square root on the bottom, I say, can't do that. So I'm going to get rid of this square root in front of the 3 by multiplying by the same exact square root of 3. Cool? Everyone look at me? Next phone? All right, now, here we go. Here's what I want you to do. Kind of scratch out that equal sign. We're not there yet. I see square root of 3 on the bottom. I know that means I need to multiply by the same square root of 3. That'll eliminate the square root. Okay? Now here's the deal. If I do it on the bottom of the fraction, I'm going to have to also do it on the top of the fraction. Keeps it the same. So, boom. All right, now here's something that can be tricky. Let's see how smart y'all are. What is 2 times the square root of 3? What do y'all think? Not 6. Not 3. It's not square root of 6. See how these things are different? One's a square root, one's not. Okay? Whenever you have a number and a square root and you're multiplying, you just put them next to each other. That's it. Okay? So 2 times square root of 3 is just 2 square root of 3. Okay? So don't actually multiply these unless they're both square roots or if they're both regular numbers. You know what I'm saying? If they don't match up, stick them next to each other. 2 times the square root of 3 is 2 square root of 3. Now on the bottom, we talked about this. Square root times itself removes the square root. What's left over? 3, okay? Now that's an uglier looking fraction, but at least we have a regular number on the bottom. We have rationalized the denominator. Square roots are irrational, but now we have a rational denominator. Okay, so that's pretty much it. So let's do 7 and 8 together. Number 7, do I have a square root on the bottom? I do. That's a no-no. So how do I get rid of a square root on the bottom? Times the same square root, right? So get rid of that equals. I don't need that yet. So again, no square root on the bottom, so times the same square root of 2 on the bottom and on the top. On top, 8 times the square root of 2 is what? 8 square root of 2. Remember, regular number, square root sign. You put them next to each other, right? Feel me? So, on the bottom, square root of 2 times square root of 2 is regular old 2, okay? Now, hold up. You see how the 8 and the 2 are just regular numbers. They're not square roots. If you can, you want to reduce them, okay? So the ones we just did before, or the first one, 2 over 3 did not reduce, right? But right here, 8 over 2 does reduce. What's 8 divided by 2? 4. So let's write that down. Equals 4. And then the square root of 2 still is there next to it. Cool. It's kind of weird, but you can do it. Number 8. A square root is on the bottom. That's a no-no. So let's first scratch out that equals. I'm going to multiply by the same square root of 3 on the bottom. And if I do it on the bottom, I'm going to do it on the top. All right. 9 times the square root of 3 is 9 square root of 3. And then on the bottom, square root of 3 times square root of 3 is just 3, right? Square root times itself removes the square root sign. And then, can I reduce those whole numbers, or the coefficients? Yeah, 9 over 3 is what? 3. Bring down the square root of 3 next to it. Okay, I'll give you all a minute. I want you to try number 9 and 10. So times square root of 2 on the bottom and the top. So the top will be 7 times square root of 2. 7 square root of 2. The bottom is 2. Did everyone get that? 7 over 2 doesn't reduce to a whole number, so we leave it. Number 10, again, square root of 3 on the bottom, can't have it, times the square root of 3 on the bottom and the top. 8 square root of 3 on top, 3 on the bottom. Okay? So you reduce it when you can, if you can. And we have one last thing to learn about square roots. Flip it over. This is going to be not too hard, I promise. Okay? Okay, adding and subtracting. We've done a lot. We've done simplifying, multiplying by the same thing, dividing, rationalizing denominators. We've done a lot of stuff, but this is the last thing, and it's not too bad. Now, this is not square roots at the top, but this is stuff called combining like terms. You might remember it, okay? If I have 2x and 3x, and I add them together, 2x plus 3x is how much x? 5x. Easy, right? No big deal. What about subtracting? 7x minus 5x. 2x. Don't get tricked here. What is 5x plus 3y? Very good. 5x plus 3y. Everybody looking up here? That phone? If one's an x and one's a y, they do not combine. You just rewrite it, okay? You can only combine it if it matches. So don't force it unless they're the same. Now, square roots are the same idea. 2 square root of 3 plus 5 square root of 3 is how many square root of 3? Yeah, so 2 plus 5 out front is 7. Square root, not 6, not 9. The square root stays the same, okay? Just like when you had x's, the x stayed the same, right? So when you add and subtract, the square root sign stays the exact same. Cool? So 2 square root of 3 plus 5 square root of 3 is 7 square root of 3. That's it. Next to it, if there's no number in front, it's an implied 1. Write it if it helps you. But what is 4 square root of 3 plus a 1 square root of 3? 5 square root of 3. There's an implied 1 there. So write it if it helps you. Now, subtracting is the same idea. 5 square root of 7 minus 3 square root of 7 is how much square root of 7? So 5 minus 3? 2. Square root of 7 stays the same, right? Again, implied 1 here. 2 minus 1. is a 1 square root of 3, or you can just write it square root of 3. All right. Let's do these real quick together. 2 square root of 3 plus 4 square root of 3. What do y'all think? 6 square root of 3. Easy. Okay. What about 8 square root of 5 minus 4 square root of 5? Okay. Again, implied 1 here. 3 square root of 2 minus a 1 square root of 2. Now, what's weird about number 4? The square root of 7 and the square root of 5. They're not the same, right? So, what do y'all think? What do we do with that? Okay. Well, if I combine 3 plus 2 and get 5, but what would the square root be? So, you remember this right here? 5x plus 3y is 5x plus 3y. You can't add them unless they match. Okay? So same thing goes with square roots. Square root of 7 and square root of 5, you actually cannot add them. They don't match up. Cool? So not to trick you, but that's the idea. You just rewrite it if they don't match up. Okay? Does everyone get that? If you're on the phone, look up here. If the square roots don't match up, then you just rewrite exactly what you had before. You can't simplify it more. It's already simplified. Okay? Now number 5. 5 has different square roots, but look right here. There's a square root of 3 and a square root of 3. Those two can combine. So let's combine them. What's 2 square root of 3 minus 3 square root of 3? Negative 1 square root of 3. Now I'm going to write that as negative square root of 3. The 1 is implied. But that minus square root of 5 doesn't mix. So what do I do with that? Just write it right next to it the way you had it, okay? So do you see how sometimes you just combine what you can, and then whatever's left over, you write it down? Cool? Stay with me. We're almost done. If you're looking at a phone, don't look at a phone. Look up here. We're almost done. So, number 6. 8 square root of 2 minus 7 square root of 2. What do I get? 1 square root of 2, or just square root of 2. Now, number 7. Can I combine all three of those? Square root of 2, square root of 2, square root of 2. They're all the same square root. Yeah, add them all up. What's 3 plus 4 minus 8? Okay. So 3 plus 4 is 7. 7 minus 8 is negative 1. Square root of 2. So negative square root of 2. And 10 minus 5 is 5 square root of 5. Those match up. Now, y'all ready? One last trick up my sleeve. Number 9. Can I add those together? Okay, well, what would I get? You can't add the insides of the square root. So no, not 20, not square root of 20. Do the square root signs match up? Okay, so you're onto something. I think that's what you're saying. So right now you can't add them. They're not the same, right? But this square root of 2 is prime, but 18 is not prime. Maybe we can break the 18 down, you know, like the factor tree style. So you might need to write small. Well, let's break down 18. 18 is 2 times what? 9, right? And then 9 is what times what? 3 times 3. Now, do I have a pair there? I do. Since I have a pair of 3, I can actually rewrite this square root sign, right? So here's the deal. I'm going to rewrite this. The square root of 2 is going to be first, and I'm going to rewrite this as what? 3 square root of 2. 3 is the pair, 2 is the loner. So I just rewrote this, and now do they match up with the square roots? They do. So my 1 square root of 2 plus my 3 square root of 2 is how much? 1 plus 3, right? 4 square root of 2. And it does help to always write that 1 sometimes. Okay. Now 10 is just same idea. If you have a square root of 27 and a square root of 3, you can't add them the way they are. Well, let's break down 27. 3 times 9, 3 times 3. I have a pair of 3 and a loner 3. So it's going to be 3 squared root of 3 minus the square root of 3. So that's an implied 1. 3 minus 1 is 2 square root of 3. So again, when it's asking you to subtract or add, if you can, you want to break down any square roots that are not simplified. Okay. Now, all of the notes from all this week you're going to use to work on this assignment, which we don't have a ton of time on, so we'll have additional time on Monday to work on this. So if you don't finish it, don't sweat it. We'll have extra time. Okay. But we're going to get started.